Good evening, students. I hope I'm audible to all of you. If yes, you can drop yes in the chat. Okay, great. Thanks for confirming that. We will be starting the session in the next 5 minutes. Okay. Meanwhile, you can inform all your friends to join in the session as well. I hope you're all getting your regular updates in your Telegram group. We will be starting the session in the next 5 minutes. Okay. Yes. Good evening once again. We will be starting the session in the next 3 minutes. Okay. Please inform others to join in as well. We have already sent the link and details in the Telegram group. Okay. And Bal Ganesh Bali Reddy. I can see a comment in the YouTube asking for how to join this internship through AICTE portal. The answer is in your question itself, right? You have to apply for it in the AICTE portal for the next batch, I mean. You've already applied for this May batch internship and you're here. Like if there are any upcoming internships, we will keep you posted in the AICTE platform. Okay, and one more thing, those who are attending this internship this month, you're not supposed to attend the next month's internship. So please note that as well. This applies to the May batch, April batch as well. Right, I hope I answered your question, Balaganesh. Please don't post the same thing again and again in the chat, guys. Don't spam it. Two more minutes. We're waiting for other students to join in as well. Yeah, and some of you are asking when is the last day to submit the project. Even in the chat on Zoom, I can see Deekshit has asked for it. So the last date to submit your project is 15th June 2025. Right? You still have time, right? We still have 25 or 26 days. But we would suggest you to start working on your project. In the sessions, the trainers are also giving you the inputs. So you can just start with your project. Get the project started. Final date to submit is 15th June. You can do one project. Rukin. Certificate. Okay, completion certificate you will only receive after 15th of June. Okay, because the deadline given for the project submission itself is 15th June, right? So we'll have to process all of the submitted details, and then only we can initiate your internship completion certificate. You will get it in the LMS itself. What project you have to submit, the trainers will keep you posted on the same during your sessions. Please keep attending the sessions. Do not miss anything. Let me start the recording. Right. So good evening once again, everybody. There are certain things that that we wanted to share with you. One, please complete all your mandatory courses. In your LMS, there are three sections: basic, intermediate, and advanced. So please ensure for the May batch students, you need to complete the courses under intermediate and advanced. There are 9 courses in total. Okay, please don't get yourself confused with modules and courses. Courses are different, modules are different. Okay, so please ensure that you complete whatever courses available under intermediate and advanced section of your LMS. Okay. Number 2, check your Telegram group. There we have sent you a Google form. Okay. You can ask me, ma'am, what is the use of it? If you could read the description of that form, you get to understand that it is for the FSP students who had this issue with the OTP thing. Okay, so the detailed instruction is already given in the Telegram group. So use the form if it is not still working for you, means we will get that sorted. Okay, the form link is there in the Telegram group itself. And that form is only for the students who have this OTP issue with the FSP platform. Okay, so that is the second update. Third, those who missed the sessions. Even I've been seeing the queries like, ma'am, I missed the session, I missed the attendance, I couldn't find the recordings. See, all those information is already available in your Telegram group. Go to the pinned messages, just have a scroll up. You'll be able to see all the messages. Be it the attendance links for your missed sessions, the recordings of your missed sessions, all the details are already there in your Telegram group's pinned messages. Okay, so do check them and work on your courses and other things, registrations or whatever it is. All those things are available in your Telegram group since the orientation itself. Okay, so all those sessions, recordings and everything is in your group. Do check them. And you all need to do your projects individually. Because we've been seeing that some students are asking, ma'am, can we do it as a team? My 2 friends are also in this internship. Can we do it as a team? No, it should be your individual project. Clear, all of you? If it is clear, you can send me clear in the chat. It should be your individual projects. What type of projects? The trainers will keep you posted on the same during your sessions. Okay. But one thing I can tell you is the project title you can choose. You can do it on any topic, but it should be a base. It should have a base of artificial intelligence, because that is what the program's main objective, right? So it should be based on artificial intelligence, but the trainers will keep you posted about what they exactly require. Okay. So it should be an individual project. I think with this note, let me hand over the session to Tawfiq sir or Rohida sir. Thank you.
Very good evening, students. Am I audible? Students, can you hear me?
Yes, sir, you're
Okay.
audible.
Yes. Okay. Previous week we had sessions related to artificial intelligence, and we had also discussed about generative AI, right? Now, we'll just have a lead here. So, from today's session, we're going to have the practical implementation as well. We're going to start with machine learning, and we'll have some hands-on practical implementation as well. Before that, let me just share my screen. Yes. So students, just let me know, is my screen visible? Drop your messages in the chat box. Yes, good. And drop me a message as well, like, is my voice clear and audible? Is there any disturbance? No, right? Yes, good. So, as we had discussed earlier, we studied about artificial intelligence. Now, just give me a quick definition about like what is artificial intelligence. Post your answers in the chat box. What is artificial intelligence? You can make it a short message. What exactly it is? Okay, it is a technology. Okay, mimics like a human brain. Okay, good. Human intelligence. Okay, simulate human intelligence. Yes, good. Yes. Okay. So, what you can just refer is like you can just make it a simple and understandable definition. That is, AI is a technology that enables a computer or machine to simulate the human intelligence. That's what artificial intelligence is, right? And if somebody asks what is machine learning, what you gonna answer for that? What are you gonna give the answer for that about machine learning? Previously we had a discussion, right, about like how it is related to AI, what about deep learning, about uh, other thing we had discussed, generative AI, how exactly it is related. Yeah. So machine learning is a subset of AI, right? It is a part of machine learning is a part of artificial intelligence. Yes. Okay. So let's see what exactly we're going to cover today. Yes. We're going to have a discussion about like what is machine learning. We're going to have a strong understanding the application of machine learning as well. We'll see the flow of machine learning. We'll also see the types of machine learning. We'll discuss about supervised learning. Then inside supervised learning, what are the types will come? Like it's something like regression and classification. After that, we're gonna have unsupervised learning, and we also gonna see the evaluation metrics. Okay, and so in today's session, we're also going to cover one of the real-time project which is related to machine learning. So I'll not drag too much in the theoretical concept. We're going to have a small and understandable definition about machine learning. Then we'll just land up into the problem statement. And in the next day, on Thursday, again, we're going to have a continuation of the machine learning with other problem statement. Okay. So on each day, we'll be having one or the other project. Okay. So previously we had a understanding about machine learning, right? So can anyone give me the definition, like what exactly is machine learning in simple terms, apart from the technical terms, to make it more understandable? How can you define the machine learning? How can you define machine learning? What exactly is machine learning is? Okay, to make the predictions, training the machine. Okay, yes. Okay, so in simple terms, you can just tell that machine learning is nothing but you're training the machine. Okay, so once your machine is getting trained on the data what you provide, your machine will learn the patterns, it will understand the data, And by understanding the patterns, what your machine is going to do, it's going to give the predictions for you. It's going to give the output for you. Okay. So this is the technical definition what we're going to refer. Okay. Machine learning is a subset of AI that allows for optimization. When set up correctly, it helps you to make the prediction. Okay. So that is what the technical definition tells about. So this is the landscape of the entire process here. Like you can see how exactly it is related to each other. There is an entire branch called computer science, and inside computer science there is artificial intelligence, that is AI. Within AI, there is another subset, that is machine learning. And in machine learning also, there are few classifications what it has been made, right? One is unsupervised learning, we have supervised learning, we have reinforcement learning. By taking the combination of each and everything, you can see how exactly the deep learning has been formed here, right? So that is how you can just describe it. Okay, so have it a look again. So the entire branch, that is computer science, and from computer science there is a branch called artificial intelligence. Inside that, machine learning comes. Again, it's going to be classified like unsupervised learning, supervised learning, and the reinforcement learning. By taking all the things, it's been gathered and the deep learning has been formed. Okay. So this is how the workflow will go in machine learning. First, we're going to define a problem statement. Okay, so whenever you start with any kind of machine learning project, if you want to build any model related to machine learning, first and foremost thing, what you have to do is you have to understand the problem statement very well. So if you understand the problem statement and what the client requires, it is easier to build the model, right? So once the problem statement is been understood, the next thing is collect and prepare the data. Okay, so the next step is you have to either collect the data by doing a lot of surveys. The second scenario is either you can collect the data from the stakeholder or the client who is giving the project for you. Okay, that will be two scenarios how you're gonna collect the data. The third step is develop the machine learning model. All right. So the data what you have taken out, you'll be doing whole bunch of pre-processing. You'll be cleaning the data, you'll be doing a lot of encoding, pre-processing, etc. After that, you'll have to think what kind of model you have to build for that. Okay, so mainly you have to see whether it is a classification model what you have to select, or the regression model. In the regression model, which algorithm is giving the best result for you. Okay, so that kind of things you have to be sure at. The next thing is test and refine machine learning model, which means once you build any kind of machine learning model, okay, it's not like you'll get 100% accuracy. No, it's not like that. Okay, if you're taking one kind of model algorithm, once you build that, there'll be some invalid answers what will be given by your machine. Okay, so you have to rectify that, which means you have to enhance your model, which means you have to do lot of improvements, which means you have to do hyperparameter tuning to improve the accuracy. If your model is not behaving well, you have to pre-check the data what mistakes you have done in that. The next step would be the deployment, which means once you build the entire machine learning model, you're gonna uh, deploy or you're gonna publish your project to the online server. The next step is manage prediction services. You will be giving the access, like how and who can access your project. Is that understood, everyone? Is it a yes? Students, have you understood how exactly the flow will be of machine learning? Any doubts? Yes. Okay. Now, these are the few real-time case studies, right? One is the crop recommendation. You can take COVID-19, sale forecasting, fraud detection. Okay, you can take any kind of real-time case studies. Okay, if we talk about crop recommendation, Okay, so first we have to collect the data related to agriculture, right? We'll collect the data of the land, specific land, where you can just grow the where you can grow your yields, or where you can grow the crops, or etc. You'll see the factors of the data, whether it might be the soil, potassium content inside that. A lot of different data will be there. Based on that, your model will understand like what is the level of that and what kind of crops can be grown over there. It will check the humidity, what is the temperature over there in the land. Based on each and every factor, your model will predict what kind of crops can be grown over there. If we talk about COVID-19, so COVID played a huge impact, right? So it was a really hectic time when the entire world faced the COVID. So if you take the data of COVID, so you can just predict like what are the time it was highly affected, right? Other scenarios you can just detect like who was affected by COVID and what are the states or countries were affected a lot. You can do a whole bunch of analysis by using that as well. Then if you talk about self forecasting, you can just take previous 5 or 6 years of data, and based on the data you can predict the upcoming sales, whether it might be for your company or something. Okay, so if you have a sales repeatedly going on, the same data you can just fit to your model. Your model will understand the pattern, and based on the pattern what your model has learned, it will try to give the prediction what is the expected sale you can expect for upcoming days. Okay, the next thing would be like fraud detection as well. Fraud detection means like whether the credit card fraud or something. Okay, transaction for frauds, right? So there are a lot of scenarios like fraudulent transactions are going on, right? So that kind of things can be prevented. Okay, these are the few real-time case studies what we can have a discussion about. Any doubts still here? Is it understood? Yes. Yep. Now we're gonna have a discussion about like the types. What are the different types in machine learning? We'll understand in detail like what exactly it is and how exactly it can be solved. The first type is nothing but supervised learning. The other type is unsupervised, and the reinforcement learning. So basically, machine learning have three types. These are the types here. The first type is nothing but supervised learning. Second is unsupervised learning, and the third one is reinforcement learning. Yes. Whenever we come across supervised learning, okay, you have to understand one thing. We deal with the label data. The concept itself, it tells, it focuses on the label data. Whatever the data we'll be collecting, there'll be the labels, what we are trying to predict. That's nothing but your supervised learning. Okay, so in simple terms, what we can just expect is, okay, so if you have some random data, let's believe that you have the raw data, you don't have any sort of idea what exactly you need to do. Okay, based on the raw data there will be a column called labels. Over there you can see in the chart, you can see there is something called label data, right? So in the label data you can see there are different vegetables, what it has been mentioned, right? It's been highlighted: tomatoes, capsicum, and the uh, carrot, right? So basically, by end of the model, if you build any kind of machine learning model, you will be predicting one or the other specific category. Okay, out of which whatever the data you provide, based on that your model will predict either of the vegetable here. Either it can predict it is bell pepper, either it can predict carrot or tomato. Okay, so this is nothing but the label data. So basically what I'm trying to tell here is, whenever the term comes supervised learning, you can simply assume that you'll be having some sort of idea what exactly you're trying to predict. Either you are predicting the bell pepper, carrot, or the tomato. You'll be having an idea. You have to predict one of the vegetable among this. That's nothing but your supervised learning is. Clear? Students, have you understood what is supervised learning now? Is it clear? Yes. Okay. Now, whenever we talk about unsupervised learning, in unsupervised learning, we'll not be having the labels, which means whatever the problem statement we'll be facing, that will be dependent on unlabeled data. There will be no labels. That's nothing but your unsupervised learning is. So, which means we'll work on unlabeled data. You don't have any sort of idea what exactly you're trying to predict. Okay, so in such factor, what you can do, you're gonna create the groups, you're gonna create the clusters. In simple terms, what we can tell is unsupervised learning basically focuses on creating the clusters. Okay, okay, we're gonna talk about one more type of one more type of learning, that is reinforcement learning. Okay, so reinforcement learning is also one of the approach where we call it as reward and the sorry, where we can call it as action and reward or error and reward. Okay, so in simple terms, what we can just tell is your model will learn the behavior based on the environment it has been set up. Okay, what happens in reinforcement learning here? Your model will learn the behavior based on the environment what you have been set up. Okay, so for an example, if your model is what obtaining some wrong outputs, what's going to happen is your model will get some penalty, and based on that it's going to improve the things again. Okay, so if your model is doing pretty good, it will be given some reward so that it can go ahead with a similar kind of situation. Okay, so in simple terms, what you can remember is your model will get trained based on the environment what it has been set up. It will learn the behavior. Your model will learn the behavior based on the environment what you are providing to that. Okay, that are the three types of learning. Let me just take a quick recap again. The one of the learning was supervised learning. In supervised learning, we already discussed, we'll deal with the label data, which means we'll be having some sort of idea what exactly we are trying to predict. Either we have to predict tomato, carrot, or bell pepper, right? So that's nothing but your supervised learning. And when we talk about unsupervised learning, we'll deal with the unlabeled data. We'll not be having any kind of label column. We have no idea what exactly we need to predict. So in that case, we're gonna create the clusters. That's nothing but your unsupervised learning is. Then we talk about reinforcement learning. In reinforcement learning, your model will learn the behavior based on the environment. Okay, so that is what the three types of learning is. Okay, students, any doubts still here? Any doubts? Is it clear? Yes. Okay. We're gonna start with one type of learning first. Okay, and we're gonna understand what are the types inside that and like how exactly we're gonna use that. Okay. So we are starting with supervised learning. Okay, so supervised learning is being classified into two types. Okay, one is the regression and one is the classification. Now, in the given chart, you can just observe the two different things here, right? Supervised learning has been classified into two types. One is the regression and one is the classification. So let me just give a simple scenario. Can you tell me what exactly is regression? Before we start, I want your response as well. Students, can you just post your message as well in the chat box? What exactly is regression? Yeah. So in regression problem statement, we deal with the continuous values, continuous numbers. Exactly. right? So whenever the term comes regression, you have to keep one thing in mind: whatever the outcome you are trying to predict, that will be in the form of numbers, continuous values, continuous numbers. It is not fixed, it goes on. Like if you take example 1, 10, 100,000, lakhs, 10 lakhs, crores, right? It goes on. So there is no limitation, there is no stoppage. That's nothing but your regression is. Okay. And whenever we talk about classification, okay, so mainly we are trying to do the classification here, which means we are classifying between the things. Okay. Whether we are classifying whether a person is male or a female, whether a person is good or a bad, then whether it is raining or not raining. This is nothing but the classification. Okay. Whether the question is true or false. Okay. These are nothing but the classification problems. Good or bad, yes or no, right? So this kind of problem statements are nothing but classification. Okay. So in more detail, let us have a look by understanding the chart here. Okay, so the same example we have created for regression as well as the classification. Okay, suppose if you talk about the weather condition to identify the temperature, you can see here the question is what is the temperature going to be tomorrow? We are trying to predict the temperature. Whenever we use regression, we'll just try to predict what is the temperature. It is telling 84 degree Fahrenheit, right? Fahrenheit. So the same question, if we put it in the classification problem, we're gonna classify whether it's gonna be cold or hot. As simple as possible, right? The same question, if it comes in the regression, we are trying to predict the temperature value, whether it is 82 Fahrenheit, 83, 85, etc. But whenever we talk about classification, we talk about whether the weather is cold or hot. This becomes the classification. If we talk about other example, predicting the house price. Okay. Now, based on the data, if you are trying to predict what will be the value of that house, okay, it will give some sort of amount, right? So it is giving 200K dollars. This is nothing but the regression. It is the amount 200K dollars. Okay. If we talk about the classification, we can easily tell that it is affordable or it is expensive, whether the house is expensive or affordable. This becomes your classification. Whenever we talk about regression for the same problem statement, we are trying to predict the price of the house. That's nothing but the regression problem is. I believe that you have understood what exactly is classification and the regression now. Students, is it understood? Yes. Okay, so a few of them have still doubt. Like I can just give it a quick recap again for regression and classification. See, you have to remember one thing in mind. Whenever the term comes regression, you are dealing with the numbers, continuous values. The prediction, whatever you are taking out, it will be the continuous values, the numbers. Okay. If you are taking the classification problem statement, you are classifying whether the house is affordable or it is expensive, whether the house is good or it is bad, right? Whether it is what in the city or outside the city, something like that. Okay, it can be anything. Classification means you are classifying good or bad. It is what new or old, something like this. Okay, this is nothing but the classification is. Okay, now these are the few algorithms which are coming in the classification, regression, and clustering. Okay, so if you talk about regression problems, these are the algorithms what we're gonna use. One is the linear regression. We have multiple linear regression, polynomial regression. We have ridge regression, lasso regression, support vector regression, and decision tree regression. Okay, not only this, we have few more. Okay, so for just making you understand, like we have given few examples here. When we talk about classification problem, we have logistic regression. Okay, naive Bayes, k nearest neighbor, decision tree. We have support vector machine. We also have random forest. Okay, So these are the example for the classification. For clustering also, what we have not yet started. I'm just briefing you about the algorithms here. You can see it is key means, mean shift, DB scan, and hierarchical clustering. Okay, so these are the algorithms what we're gonna study in upcoming days. Okay, before that, we'll start with the regression problem. Okay, so to understand the regression problem statement, I have a simple example here. I'll explain the chart and the graph, and after that, we'll directly land into the problem statement. Other things, when we start with classification, we can have a discussion. First, completely we'll focus on the regression problem statement here. Okay. Now, the technical definition of the linear regression is you can see that linear regression helps you to find the relationship between one variable and uh, one or more other variables. Okay, you are trying to find the relationship between one independent variable along with the one dependent variable along with the multiple independent variables. That is what linear regression tells. Okay, to understand in a simpler way, what I'll be doing, you can see the chart is been given, right? In this specific chart, you can see there are two axes. In the x-axis, we have a column called experience. In the y-axis, we have salary, right? Now, you can see in the experience column, we have the experience of a person, 2, 4, 6, 8, and 10. And we have a column called salary where we have the salaries of the people here. That is 40, 60, 80, 1 lakh, and 1.2 lakhs, right? Now, the green color points, what you are seeing, those are called as the data points. Okay, the green color points, what you are seeing, those are considered as the data points. And the line, what it is being created exactly in between the data point, that is nothing but the regression line. Okay, even we call it as the best fit line. Either we call the line as best fit line, or we can go ahead with the regression line. Okay, now to calculate the linear regression, we have a simple and easiest formula, that is y equal to mx plus c. Okay, so you can consider this example. Y is nothing but your dependent variable. Okay, I gave the example of mx. M basically means it's nothing but the slope value. X becomes the experience or one of the independent variable, and c becomes the intercept value. So these are the mathematical terms. If you are really not good at maths, no need to worry. You can just understand a simple formula, that is linear regression has y equal to mx plus c, a simple and easiest formula what you can remember. Okay, and now you can just have a look. Based on the formula, this regression line would be created out. Okay, now let us see how exactly it is related to linear regression. Now previously I told that uh, I have a column called experience, and based on the experience column we are trying to predict the salary. Okay, that is my problem statement. In this problem statement, what I want to build here, I want to build a machine learning model. If I just randomly pass the experience of a person, okay, your model should tell what is the exact salary of that person. Okay, to build that kind of model, we require the data first. Okay, so that once we take the data, I can just train for my machine learning model. Your model will understand the pattern, it will try to predict the data for you. Okay, so that is the expectation what I have. Okay, to do that, let us see how exactly the data points has been created out. Now let's believe that approx we have 3,000, 4,000 students who are attending the session now, right? So if I just randomly ask if you have done any kind of job, okay, I'll be asking like how many years of experience you will be having and what is the salary you are having. I'll do the manual survey. Okay, now I'll just call the person one, and person one will tell that the person is having 2 years of experience and he has the salary of 60,000. Just an example, I'm giving an example, right? I'm not telling you this is the real scenario. So what I'll do, there's a person, let me just highlight here. Okay, there's a person who is having 2 years of experience and he will tell that he has a salary of 60,000. So if the person is having 60,000 salary of 2 years, So a data point, something like this, the red color X mark what I have created, similar to that, the data point would be created. Now there is another person who is having the experience of 3 years. He is having only 20,000. For 20,000, uh, the data point would be coming somewhere at the bottom. You can see another data point has been created out. Okay, so like this, all the green color data points has been formed here. Okay, now you might be thinking that what is the relation for the data point and the line what is been created out, right? So that is a major question here. So in linear regression, what happens is you have to create a regression line. You have to create a best fit line. Okay, now let me just tell why exactly you need to create a regression line here. Okay, now let's believe that. Let me just take a marker here. Just a minute. Yeah. Okay. So this is my data point. Okay, let's believe that. Don't concentrate on the line what it has been already drawn. Okay, I'll just create another line now. Imagine that based on the data, your model has created a line somewhere here, something like this. Okay, now what happens is your model will give some prediction. Okay, now that prediction you have to check with the actual value. Okay, now what is the actual value? The green color dots or the green color data points what you are seeing, those are nothing but the actual point, and the line what it has been passing, it's nothing but your predicted point. Okay, now if the actual value of a person is 42,000, here it might be some 42 or 43,000. Okay, your model will predict somewhere here. Your model will tell that the person is having approx 55,000 or more than 50,000. Okay, now the distance between the actual point and the predicted point, this is nothing but your error rate. This is nothing but your error rate. So what you have to do in linear regression, you have to be sure that the line what you have created, the regression line what you have created, it should be having the less error rate. Okay, if you take this all the data points by averaging all the data point, the error rate should be minimum. Okay, so if you create a regression line here, if you take the average of all the data point, there will be huge error rate. Why? Because this will be your predicted value and this will be your actual value. The distance is too high. You have to reduce that error rate. To reduce that error rate, you have to create a regression line exactly in between, where the upon averaging the error rate should be very small. Okay, that is what your linear regression algorithm tells you. Okay, student, is that clear? How exactly are you going to create the linear regression algorithm? Any doubt in this? Yes. Okay. I know that a lot of students are asking, I wanted to hear it one more time. Okay. I would request you can just go through the recordings again, because there are a lot of things what we have to cover at a short, like we cannot cover each and everything. So you can just watch the recording so that you can have a recap again. Okay. Yes, that is what your linear regression tells you about. Okay, so this is how the training process will be taken up. Okay, there will be some uh, data set here. Okay, the data set will be transferred for the algorithm. Okay, that algorithm will test all the things and it will give some predictions for you. Okay, and if the prediction is good, you'll be checking with the evaluation metric. There are a lot of evaluation metrics. Okay, we can call it as RMSC or MSC or ME, that we're going to have a discussion. So that is how the flow will be of linear regression. Okay, let us see in the practical implementation how exactly we can work with that. I'm not telling you only linear regression is one of the algorithm in regression problem statement. There are other algorithms also. Okay, we had discussed. One was ridge. We had lasso regression, polynomial regression. We have the regression from the decision tree. We have from the random forest, etc. Okay, so let's focus on to the project part. Okay, so we have a problem statement here. Okay, the problem statement is very simple. Okay, so the question is, when should we use the linear regression, right? So whenever you have the data set related to regression problem statement, in that case, you can apply the linear regression. Okay. And manually you can evaluate which algorithm is giving you the better result. Okay. You can change the model each and every time. Okay. Once you build the entire model after doing a lot of cleaning, pre-processing, etc., you'll build the model, right? So in that case, you can apply 3 or 4 different algorithms and test it out. Like whichever the model is giving the better accuracy, you can just place that, or you can finalize that specific algorithm. Yes. Okay. Let's come to the problem statement here. We have ACME Insurance Inc. Okay, let's understand what exactly it is. So ACME Insurance Inc. is one of the company. Okay, it provides the health insurance for thousands of customers over the United States. Okay, this ACME Insurance is one of the insurance company where they will provide the insurance premium for the customers all over the United States. Now, as the lead data scientist at ACME, you are tasked to with creating a automated system to estimate the annual medical expenditure for the new customers. Okay, so there are few information what the company is giving for you, such as they are giving the age, gender, BMI, children, smoking habit, and the region. So this is the data what they are providing. Okay, so let me repeat the problem statement again. Okay, ACME Insurance Inc. is one of the insurance company. Okay, where it provides the premium insurance for the customers throughout the United States. Now, in that company, you are working as a lead data scientist, and you are given a specific task that you need to build a automated system to estimate the medical expenditure for the new customer. If the new person is coming to take up the insurance in that company, if they randomly give the data such as age, gender, BMI, children, smoking habit, and the region, your model should predict what is the medical charges he will be bearing annually. Okay, so that is what the problem statement is. I believe that you have understood the problem statement now. Students, have you understood the problem statement now? Is it a yes? Yes. Okay. Now, if you just click onto the project link directly, you will land to the what GitHub folder what you will be working with. But I'll not go with the GitHub link. I'll go with the Jupyter notebook. Let me just open the Jupyter notebook here. See, student, there are multiple platforms where you can just create the project. It's not only the Jupyter notebook. You can also use Visual Studio Code. You can use Google Colab also. Okay, it's up to you. Student, just let me know, is my screen visible first? Is my problem statement along with the Jupyter notebook is been opened now? Is it a yes? Yes. Okay. Okay. So students, like already I have executed all the codes. I want you to, okay, let me maximize the screen as well, why? Because the font seems to be really small, right? Yeah. Let me do some enlargement here. Just a second. Okay. Student, is the font sufficient? Yes, Muhammad Hasibullah, like we are using the Python programming for this project. Whenever we have machine learning problem statement, we have to use the Python programming. Okay, so this is the prerequisite. We require Python programming and we require the knowledge of few Python libraries as well. Okay, I'm going to explain like how exactly this works. Okay, now this would be the project outline. Okay, a typical problem statement for machine learning, downloading the data set for machine learning, linear regression with one variable, with multiple variable, we'll see how we can just work with categorical data. Then by applying the different modeling technique by using scikit-learn. Okay, then we can also apply other different algorithms for the same data set. Okay, as I've already told, the problem statement is clear for everyone, right? So I'll not repeat it again. You can just have a look the data what it has been given here. Okay, so we have a data something like age, gender, BMI, children, smoker, region, and charges. So this is the data what we are having. Okay, so in this specific data we have approx 1300 customers. Okay, so what we have collected for. So based on the data, we are trying to predict the medical charges. We you can see there is a column called charges, right? So this is the column what we are trying to predict. Okay, students, I want your patience. Okay, so kindly watch the entire project carefully. Later on, you can just ask for the GitHub link and all. I want you to focus on the project first. Later on, I'll be sharing all the links. Okay, so the project is for you only. We'll be sharing all the materials for you, the project material especially, along with the data set. No need to worry. But the first intention should be like you have to focus onto the project part here. Okay. You can see that I'll be using a few basic libraries just to load the data first. Okay. One of the libraries pandas, import pandas as PD and numpy as NP. So pandas is one of the library for doing the data analysis. Okay. If you want to do the data analysis, you can use the pandas library to deal with the data frame. And there's another library called numpy, which is also called as numerical Python. Numpy means numerical Python for numerical computing. So these are the two libraries what I'll be using first. Okay. Now you can see I'm taking a variable called medical DF. And in that variable, what I'm doing is I'm just reading the data set. Okay. So PD basically means that I'm using pandas library specially. And I'm just reading a CSV file. Whatever the data is there, I have the data set in the form of CSV. CSV stands for comma separated values. Okay, what this CSV means? Comma separated values. So you might have gone through different file formats. You might have seen the PDF file. PDF means portable document format, right? So you might have seen Excel file. For the Excel, we have the extension called Excel SX, right? So similar to that, we have one more file called CSV, which is comma separated values. Okay. So in this specific data set, you can have a look. We have this entire data: age, gender, BMI, children, smoker, region, and charges. Okay. Now, if you just check the variable, entire data is been stored in this variable, and we have approx 1338 rows. Okay. So this entire data consists of 1338 rows and total 7 columns. Okay. So there are total 7 columns: age, gender, BMI, children, smoker, region, and the charges. So in this data, can you tell me what exact column we are trying to predict? If we are talking about regression, what is the column we can predict in this, students? Charges, exactly. Right? So age, gender, BMI, children, smoker, and region. This becomes your independent data. These are nothing but your independent variables. Okay. So based on this independent data, you're trying to predict the column called charges. Okay. Now, in simple terms, if I provide the age of a person, gender, BMI, smoking habit, and the region, your model has to predict what is the maximum medical charges that person is giving annually. That is my problem statement. Yes. Now you have understood the data very well now. We have these many columns and these many rows. 1338 records we have and 7 columns. Now, if I just use a keyword called info, it will give me the summary of the data set. Okay, so it is telling me that this is the non-null count. Like there is no such column where we have the empty values. Non-null means non-empty values. Okay, it is telling that all the values are filled with each one of the values. And we have another column called D type. Okay, so D type will tell us which column is what data type. So if you talk about age column, age is nothing but the integer data. Gender is nothing but the object. Object means the categorical values. Okay, you can have a look. We have the values like female and male, right? This becomes the object. Float means a value with the decimal digit. Again, you can see this is the value 27.9, 33.7, etc. These are nothing but the floating values. Okay, so you can have a look. Smoker, again, it is an object. Why? Because we have smoker, whether a person is yes or no. Region, southeast, southwest, what kind of region the person is. Then the charges. Okay, now understand one more thing. As the data set is from the United States, it is not the Indian rupees. Okay, don't get confused here. So the values, whatever we are having, it's the US dollars. Okay, it is the first value is nothing but $16,884. The person has given that much amount of uh, medical charges annually. Okay, this is the historical data. Based on this data, we're gonna train the machine and we can create a model to predict the upcoming new values. Is that clear for everyone? Student, shall we go ahead? Yes. Okay. Now there are few keywords what you can just refer to understand much better. Okay. Medical DF basically means the entire variable where the data is being stored. I'm using a keyword called describe. So describe gives you the statistical analysis of the numerical values. Okay. So describe gives the output of along with the statistical values. For an example, you have the age, BMI, children, and charges, right? So if we talk about age, I can get the entire statistical analysis here. The minimum age starting is 18, and the maximum age is like 64, right? Because like whenever the company is giving the insurance, they will check, they'll cross check whether a person has what or reached a minimum age criteria 18, or uh, he has crossed that age or something like that. Okay, and maximum age is 64, which means uh, this specific company will not provide the insurance for those people who is crossing the age more than 64. Okay, the company will give the insurance max to max till the age 64, and the minimum age should be 18 years. Okay, that is one thing what we have understood from this data. Then again, second column, we have something like BMI, which stand for body mass index. BMI means body mass index. Based on the height and weight of the person, the BMI will be calculated. The minimum BMI of a person is 15.96 and the maximum is 53. Okay, so students, can you just tell me what is the average BMI of a person should be? What is the BMI value on an average it should be? Yes, 23 to 25, something like that, right? Yes, exactly. So it suggests the fatness of a person. Like for an example, if you consider that the BMI is 53, the person is really fat. Okay, and if the BMI is like 15.9, or the person is very lean. Okay, and if we talk about children, the minimum value is 0, and there are few people who have a maximum of 5 children as well. Okay, and 50th percentile also called as median value, median. Okay, then we have another column called charges. In the charges you can see that there are few people who have paid only the medical charges of $1,121 annually, and there are few people who have paid like $63,770. Okay, huge difference, right? Yes. Okay, so those are the insights what we can just take out by applying a keyword called describe. Mainly it gives the statistical analysis. Okay, so we'll start about we'll work with EDA part now, exploratory data analysis. It plays a really important role. See, this is also one of the important techniques, students, which means whenever you start working with one kind of project, you have to understand the data very well. If you understand the data very well, it becomes easier to build the machine learning model. As much you understand better about the data, it becomes much easier to handle the data. Okay, for EDA part, I'm using Plotly library and Matplotlib, and I'm also using Seaborn. There are three libraries what I'm using. Seaborn, Matplotlib, and Plotly. So all these three libraries will be used for the visualization. Okay, it is not mandatory that we have to use all the three. It's optional. Either I can go with Seaborn or Matplotlib. But Plotly also creates a chart with the having some what interactive charts. Okay. Now, let's pick one specific column and let us see like how exactly that specific EDA can be performed. Okay, so I'll take the medical DF, the variable where the entire data has been stored. I'm picking a column called age. There's a column, right? Age. So I'm just taking the statistical analysis of that. The same input I'm getting. Okay, the minimum age is nothing but 18 and the maximum age is 64. Okay, now if I create a chart for this, I can get a clarity here. Okay, now you can see that I have created a histogram. Okay, I'm using px means Plotly library. From the Plotly library, I'm creating a histogram. I want the histogram from the entire medical data. I'm keeping the x-axis as I want the age column. Marginal, I want the box plot here. Okay, n means basically how many boxes I want. Those things. Title I have given, and I have created a chart for this. Now you can see that for the specific column called age, we have created a chart. Now you can understand in much better way. If I just hover the cursor on the specific first bar, that is, it is highlighting that age is nothing but 18 and the count is 69. So we understood much better now. Okay, which means we have understood one thing, that there are 69 people in the data set whose age is 18 and who came for the insurance to purchase the insurance. Okay, and there's another age category that is 19 years, and again in the 19 years we have the count of 68. And if you talk about like age 20, 21, 22, there is a distribution which is forming uniformly. There's a uniform distribution here. But if we talk about these two specific bars, age 18 and 19, there are huge count. It is crossing like more than 130 or 140 people, right? So can you just tell me like what might be the reason that age 18 and 19 have more number of data here? The age people who is having 18 and 19. See, there are multiple scenarios. What we can just assume. Okay, if you are telling that cheaper charges. See, one thing what you have to keep in mind, like a lot of insurance company, what they do is they will wait. They'll give only the insurance for those people who cross the age 18. Okay, so they'll think that okay, that person has reached the minimum criteria. They are ready to take the insurance, and we can provide the insurance for that person. Okay, the minimum age will be there in few of the companies. Okay, so that is what the ACM is following in this data set as well. Okay, yes, these are just the assumptions. Okay, don't think it is one of the case. You can just assume based on the examples. Now there is another example we are checking with BMI as well, body mass index. Okay, and again we are creating the histogram. So here you can see that again, like a lot of people have the BMI value ranging like what up to 35 max to max, right? And as the BMI is going more than 35, there are less amount of count. Okay, and you can see there are few people who is having a small amount of BMI as well, 15. The count is only one. Okay, the question is like what is bins equal to 47, right? So number of bars like what we have created. There was a question like bins equal to 47, what exactly that means? Bins means like the bars what we have created here. Those many bars will be created out. Okay, yes. Okay, this is how the actual BMI structure would look like. You can see age, sorry, not age. The people who is having the BMI which is less than 18.5, those are considered as underweight. 18.5 to 25 normal weight. 25 to 30 they are considered as overweight. 30 to 40 obese, and more than 40 morbid obese, which is also called extreme obese. Okay, so the normal BMI or normal weight what we have to keep is like around 18.5 to 25. Okay, if we are crossing more than that, we are considered that we are overweight people. Okay, yes. And how this BMI will be calculated based on the height and weight again. Okay. Then if we talk about the column called charges, you can see again I'm creating the histogram here. This time I've used Seaborn library, SNS. SNS stand for Seaborn. I want the his plot. I'm using entire medical DF data, and in the x-axis I'm using the charges, and hue I'm giving as the smoker, which means I'm highlighting the smoker categories, like who smokes and who doesn't smokes. Okay, you can see that the people who doesn't smoke, they have the least number of charges. They don't pay a lot of amount to the hospitals, right? And you can see the category called S, which is highlighting in the blue color. Okay, that means they have the habit of smoking, and their medical charges is comparatively high. You can see none of the orange color or the peach color. Sorry, it might be slight orange color. Okay, we don't have uh, value which is crossing more than 30,000, I believe. Okay, the people who is crossing the medical charges more than 30,000, they are in the what blue color character, which means they oftenly smoke. So one thing we have understood that smoker plays a really important role while building the model. Okay, your machine can understand much better if the person is having the habit of smoking. If we are giving the value, your model will predict the high value. Okay, and if the person doesn't have the habit of smoking, if we give the value as no, it will predict the least amount of value. That is one conclusion what we have came up with. Okay, so this is from the Seaborn. And again, if you want to plot the chart with the plotly library by using px, you can use other chart here. You can see the same information. It's been created with different chart, different library. Sorry, we have red color bars and we have the blue color bars. So blue color bars are nothing but they have the habit of smoking, and red colors, they don't have the habit of smoking. Okay, so you can see that a lot of people who doesn't have the habit of smoking, they have the high medical charges, like which is going like $62,000, 50,000, 64,000, etc. Okay, so that is how you can just understand each and everything by performing the EDA, which means exploratory data analysis. Again, we can also check the count of the smokers, like how many smokers are there, how many non-smokers are there. Okay, those things can be understood. You can also check based on the age and charges. You are just checking the analysis here. Okay, so this is nothing but the scatter plot. To create a scatter plot, you can see you just have to use px, which means plotly library, and I'm using a function called scatter here, and I'm passing the entire medical df, where in the x-axis I'm giving the age, in the y-axis I'm giving the charges, and I'm highlighting the smoker color to give the color, which is blue and red. Automatically the color has been selected. If you want to change the color, you can give the color as well over there. Okay, so you can see there is a slight increase here. In the x-axis we have the age column, right? So in the x-axis we have age, and in the y-axis we have the charges column. Now as the age is growing, as there is a increase in the age, automatically there is a small increase in the charges as well. Can you see this? Even the red color people are the non-smokers. See, red color people are the non-smokers here. Blue color people are the smokers. And over here, by creating a chart, we can easily understand one thing here. As the age is increasing of the people, slightly there is a increase in the medical charges as well. We are not telling that it has been increased rapidly, but there is a slight increase. Okay, so that is what we have understood from this specific ADA. Okay, so there are other things also what you can just check with it. Okay, we also have BMI and charges again. So Let's see. Okay, again, we are comparing with the smoker and the non-smokers. You can see these are the smokers followed with the BMI. If we create a chart with the charges here, non-smoker people doesn't have that much medical expenses. The people who have the habit of smoking, they have high amount of medical charges here. This is what the blue cluster is telling about, right? Red clusters are the entire category with the non-smokers. The blue colors are the smokers who is having the high amount of medical charges. Students, before going forward, just let me know, is it clear till here? Is it clear till here? I'm continuously repeating. I don't want to make the entire thing boring. Understood, right? Yes. Okay. Then we have something called correlation also. Okay. So these are the part of area, like what exactly we do, okay, to understand the data. So can anyone tell me like what exactly is correlation? What do you mean by correlation? What exactly is correlation? Or relationship between variables, exactly. Okay, so we are just checking the relationship between the columns. That's nothing but the correlation is. We are just checking how it is related. Okay, so basically you can see that I'm just checking the correlation of age and charges, how it is related. Is there is any impact? Okay, so if I just check the correlated value, it is giving 29%, which means 29% it is related, which means there will be some impact of the age. As the age increase, the charges also will get some increased. Okay, so low correlation means like there is no relationship at all. Okay, so if there is a high value changes in the age column, there will be no changes in the charges also. That is what it means. Okay, let me explain more precisely. Let me show you here. Okay. Okay, whenever we talk about correlation, you can see it always ranges from the value -1 to +1. Okay, correlation value will always range from -1 to +1. Okay, now let us see how exactly it is arranged here. Now this is called as perfect positive correlation. Okay, the first chart, what I'm displaying here, it is called as perfect positive correlation. The second chart is nothing but strong positive correlation. And the third chart is weak positive correlation. There is a correlation, but the correlation is very weak. Okay. Now in the perfect positive correlation, we can assume that the values we are getting like 90%, 95%, or 100%. This is nothing but perfect positive correlation. And whenever we talk about strong positive correlation, we can assume that the values ranging like 60%, 70%, etc. That is nothing but strong positive correlation. And whenever we call it as weak positive correlation, we can assume like the values like 15, 20, 25, etc. There is some correlation, but there is a weak correlation. Okay. And you can see this is all about the no correlation. Okay. Then we have correlation in the negative order as well. We have weak negative correlation, weak, sorry, strong negative correlation, and perfect negative correlation. Okay, but because correlation values ranges from -1 to +1. Okay, you should remember these things. If you want to check the correlation easily, what you can just do, you can just give the column name and apply the CORR method of what column. It will give the correlation value. You can see it is giving 0.29, which means 20% correlation, which means we can call it as it is some sort of weak correlation. We cannot tell that it is strong correlation. It is a weak correlation. If we talk about smoker column, you can see that it is related to 78%, which means it is having strong positive correlation. Okay, approx we are getting 80%, right? So this is the strong positive correlation. Now you might be thinking what exactly is happening in this code, right? See, whenever you want to apply the correlation, you cannot apply for categorical values. Why? Because there was a column called smoker. We had a value yes and no, right? So in such cases, what happens is if you apply the CORR function, it will throw an error. What do you have to do? You have to convert that into numbers. If you convert that into numbers, you can create the correlation. So I have made it very simple here. Whenever I have made, wherever we had the value called no, I have given a value as 0. Wherever I have a value called s, I have made the value as 1. Okay, so it becomes much easier to create a correlation now. Now I've given the charges and the smoker value, and we got the correlated value here. That is 78%. That is what correlation means. Okay, so students, have you understood till here? Is it everything clear till here? Yes. Okay. Let's start with linear regression now. Like previously, we had discussed entirely about how to work with EDA part, right? We explored the data, we understood the data. Now let us start working with the modeling part now. Okay. One thing what you have to remember is, see, we have few columns which is having the categorical data. We have a column called gender here, where we have the value called male and female, which is categorical data, object data. We need to convert this into numbers. Not only this, we have the another column called region as well, which we need to convert into numbers. Yeah, even the column called smoker as well, we have yes and no. We need to convert into numbers as well. Now, to make it more simple, what I've done, I'm filtering only the data where the people who doesn't smoke. Okay, see, to create the project very easy, I have just taken few steps here. I've created a variable called DF here. In that non-smoker DF, what I'm doing, I'm filtering the data here. So totally we had 1,338 records or the rows, right? Out of that, I'm excluding the people who had the habit of smoking. I don't want that data because let us build a small model, then let us go with that data also. Okay, to do that I have applied the simple filter. I'm taking only the data who have the habit of smoking, sorry, who doesn't have the habit of smoking. Okay, so I have filtered from the entire medical DF. There is a column called smoker, and I want only the data who has a value no in them. So you can see that entire smoker column became the values called no. And how many values we have? 1,064 values we have in that. Okay. Yes. Now, if I create a scatter plot of that specific thing, now you can see this is how the data points got created. Now, if you remember previously in machine learning, I showed you the linear regression chart, right? So you can see the green color points is nothing but the data points. And over here, the blue color points is nothing but the data points here. Okay. Now, here we have created a regression line exactly in between. So similar to this regression line, we also need to create a regression line here. Okay. So students, can you just tell me where I can create a regression line perfectly? Where exactly I need to create a regression line? Let me annotate here just for your understanding. Okay. Just tell me one thing. If I create a regression line here, is it a good regression line what I have created? Is it a yes? No. Okay. Uh, what if I just, okay, let me remove this. Let me undo this. What if I just create a regression line, something like this? Yes, right? It is quite closer. All the data points will be having less error rate, and it can also be taken from here also, right? So in this specific cluster, we have less amount of error rates. Let me remove this. Okay. Yes. Okay. Yes. I want to create a regression line somewhere over there. Okay. So to do that, let us work with some specific formula. For that, I had already told how to create a linear regression model, right? So we had a formula. What was the formula? Is anyone have any sort of idea like what exact formula I told? Y equal to mx plus c. Perfect, right? So this is the formula what we'll be using. Y equal to either it can be used as wx plus b or mx plus c, and terms and terminologies can be changed. Okay, where easily we can consider this w is nothing but the slope, b is nothing but the intercept, and this x represent the age values. Okay, the same thing what we can assume. To do that, I'm not directly using machine learning now. I'm creating a dumb model. Mathematically, I'm deriving now. I'm not here to directly go with machine learning. First, I'll create a dumb model by using that formula. Then let us create the machine learning. Okay. To do that, I've created a simple Python function. Okay. I've created a function called estimate charge, and I'm taking three parameters. One is the age, and one is the slope value, and one is the intercept value, which is given in the same formula. Okay. And I'm returning the formula. What is that formula? W into H plus B. This is the formula I'm returning. Okay. Once I execute this formula, I don't have any idea like what is the slope and what is the intercept. I don't have any sort of idea. I have the data here. Okay. So imagine this is the data and I need to create a regression line here. Okay. If my regression line exactly is coming between, that means my model is good. My model is behaving very good. Okay. If my regression line is coming somewhere at the top or at the bottom, my model is worst. Okay. To do that, first I'll just define a W value and the B value. Let us see how exactly that goes. Okay. So I can just take W value as 50 and B value as 100. I'll just run this. Okay. And the same values I'll just replicate in the function. The function what I have used, I'll just apply that and I'll create a chart of that. Once I create a chart of that specific value along with the age, W value as 50, intercept as 100, a line has been created, a regression line. Now there is a regression line here. Now this regression line, let us try to fit in this specific scatter plot here. To do that, I've created a function here. Here, you can, I'll just give the notebook for you. You can just refer this function. Okay. Once I execute this, you can see the line what we have created. The slope value with 50 and intercept value with 100. It is lying at the bottom. So can you just tell me, is my model good here? No. What if we just change the value and try it out? Okay. To do that, I'll create another simple function here. In that simple function, what I have to just do is I have created a function here. I have to just pass the W value and the B value. Okay. W will remain your slope value. B will remain your intercept value. Okay. I'll just try to run this. Now, once I run this, you can see I'm getting a value here. My line is created somewhere here. Can you tell me like whether my model is good in this case? Students? It is little near. We cannot tell it is too near. It is little near. That's it, right? So we don't uh, know whether it is exactly a good match. No, it is not at all a good match. Okay, your model is really worst. Okay, let us try to change the values. Let me just give the value as 200 this time, and here let me just give it as 700. Let us try. Okay, so as you give this, it became too closer here, and you can see the RMSE value also. We are getting 4759, right? So I was not sure like what exact to be given. I have just given this one 200 and 700. Okay, but randomly I just got a chart which has been created something like this, right? So let's do one simple thing. If I just give 40 and 60, it is not giving a good match. Okay, now okay, I'll tell you what exactly that RMS is. Don't get confused now. Just understand the flow as of now. I'll tell what exactly it is. Okay. Now you can see that even this case, your model is not giving that high accuracy. Okay. Now, once you create a regression line, let's believe that this is the regression line what we created. I believe screen is visible, right? So this is the regression line we created. Now, once we create a regression line, we will evaluate with the loss function. Okay, we can call it as either the loss function or the cost function. There are multiple loss function or the cost function. This time I'm going to use the loss function, something called RMSE, which is nothing but root mean squared error. To calculate this root mean squared error, we have a specific formula. Summation of I is to n predicted minus actual whole square divided by n. Okay, which means in this specific formula, there will be some predicted value. The red color points is nothing but your predicted value. Okay, it will be subtracted with the actual value. What is this actual value? The blue color points are nothing but the actual value. That's going to be squared and it will be divided by n. Okay, so that is nothing but your RMSE. So RMSE is nothing but it's one of your evaluation metrics. Okay, the final conclusion I'll be telling in a bit by end of the session. No need to panic here. Just remember one thing. To calculate RMSE, we have a formula: predicted value minus actual value whole square divided by n. That becomes your RMSE formula. Okay, so if you don't want to create a manual function, also no need to worry. We have the libraries in Python. If you just use the name of the function, the libraries can be the function can be executed. Okay, yes, you just have to understand the concept. That's it. Now let us see what exactly that RMSE defines. Now you can see there will be some regression line, right? And there will be actual point and there will be some uh, predicted point. The distance between the green color arrow, what you are seeing, the distance between the actual point to the predicted point, that's nothing but the error rate, which is also called as residuals. The error rate. You can see in the specific chart I have highlighted. I have the point data, we have the residuals, and we have the regression line. No, RMSE is not the standard deviation. Standard deviation is something else. Okay. So RMSE is one of the evaluation metrics to cross check how your value is giving. Okay. So no need to worry. I'll just, once we get the output now, I'll just tell you like how you can evaluate the RMSE. Okay. I'll just disclose that. Okay. Now what I'm doing is I have created a function for RMSE as well. Okay. That is root mean squared error. Okay. Now RMSE takes the two things, targets and predictions. What is this targets? Your targets is nothing but the actual values. Okay. Your actual values are nothing but the targets and predictions is nothing but your predicted data. Okay. So if you want to check the RMSE, root mean squared error, you have to pass two things, right? You have to check the predicted value and you have to pass the actual value so that you can just compare it. Right? Now the formula again, it is summation of I is to n predicted minus actual whole square divided by n. The same formula I have applied here. See again, I'm telling no need to refer this formula. I'm just for making you understand. I have created this formula here. Okay. So this time I have given the slope value as 50 and intercept value as 100, and I'm giving the try parameters. And if I just give the try parameters, you can see the regression line got created at the bottom and followed with I have something called RMSE value, that is 8461. Now let us understand what exactly we are getting, how exactly you can evaluate this value. Okay. Now suppose let's believe that I have a specific actual data. In my actual data, there is a value called 20,000. Okay, the actual value is 20,000 and your RMSE value is 8,000. Okay, now you're off by that value, which means instead of 20,000, your model will either show it is 12,000 or 13,000. Why? Because it is showing that much of loss, 8,461, right? You are getting that much of difference. Okay, you can just try to evaluate something like that. If the actual value is 50,000 and your RMSE is 10,000, which means you're off by 10,000, which means your predicted value will be 40,000. Instead of showing 50,000, your model is predicting 40,000. That is how example it is. Yes, that is how you can just match up with the RMSE. Okay. Now remember one more thing. We are working with non-smokers data here. We have easy cluster here. It is much more understandable. We have not included the entire data here. We are dealing with only non-smokers. Okay. Yes. Okay. Now that was the entire thing. Now let us go ahead with the machine learning now. Okay. This is the same thing what we have given out with try parameters with different values I've given out. I've given this time 50 as a slope, 4000 as the intercept value. We are getting the RMSE of 6096. Okay. Let's try to implement the machine learning now. Previously, we did the manual calculation. Okay, that was not at all required. Just to learn few things, we have just derived that. But in this case, what we can just do is to work with machine learning, you have to use one of the library called as sklearn. Okay. Now that sklearn stands for scikit-learn. Okay, sklearn means it is the scikit-learn library, and I'm importing the algorithm called as linear regression. I want to use that algorithm now. Okay, it is that simple. From the sklearn library, I want to use the linear model, and I want to import the linear regression. Now, what I'll be doing once I use this, I'll create a variable called model, and to that model, I'll just simply assign I want to use the linear regression algorithm. Okay, you can have a look. Model is nothing but our linear regression now. Okay, now if you just check what is your model is giving something called linear regression. Okay, now understand one thing. We are working with simple linear regression, which means one independent variable and one dependent variable. I'm only checking the age column. Based on the age, I'm taking out the charges now. Okay, now what I'll be doing, I'll just give the inputs here. My input is nothing but only the age. Okay, and what is my target? My target is nothing but the column called charges. Okay, so remember one thing, input is nothing but age. You're giving all the inputs now. Input in the sense like these are the actual values, you can just go through that, and we have the answers for that also. Okay, so you are just giving this entire data for the model so that it can learn the pattern. Okay, you will tell that there is a person called age 17 and this is the medical charges for that person. For 17 it is like 30,000 or 25,000. For this is just an example what I'm telling. Okay, so input is nothing but your independent variable, target is nothing but your dependent variable. Based on the input, your target also will be taken out. Okay, so you can see that I'm taking only the non-smoker data now, which is having 1064 rows. Okay, now I'll just create inputs and target. It's been done. Now to train my model, what I'll be doing, to train my model, I have created a model here. That's nothing but linear regression. So now what you'll be doing, we'll just tell model.fit. Your model is nothing but the linear regression. And what you'll do, you'll apply the fit function. And in that fit function, you'll just give all the inputs also and all the targets also. You're fitting the inputs as well as the targets. Once you do that, you can see that your model got trained now. What happened here? Your model now got trained. Now, once your model has been trained, what happens? You need to take out the prediction. Now, to take the prediction, what you can do is you can apply the keyword called predict. Okay, so your model is nothing but linear regression. In this model, linear regression algorithm is there, which have learned all the data, and you'll apply the predict function. Okay, in the predict function, what you'll do, you'll just give the numpy array, you'll give the age value. Okay, so in this case, you can see I have given the age called 23, 50, and 60. I can also change this. Okay, so here I'll just give the age as 19. Here I'll just give 44, and here I'll just give as 53. Okay, it is not fixed here. I want to give only three values. I can give few more values also. I can also give again 61 also, and I'll just try to run this. Okay, one more square bracket has been missed. Okay, now once I execute this, you can see for the age 19, your model is telling that the person will be having the medical expenses of $2,986. For age 44, 9,667. For age 53, it is your model is telling 12,072, and as age 61, it is giving 14,212. Now, if you remember in the chart, you can see there was a slight increase in the medical charges as the age was increasing. That is what your model has learned from this, because you have given only the age column. Don't get confused here, right? So as the age is increasing, your medical charges also will be increasing. That is what we have understood. Even your model has also understood that. This is the simple explanation of the linear regression with one variable. Students, clear till here? Is it clear? Shall we go with the multiple linear regression now? Yes. Okay. So this was the example of single linear regression. Let's go with multiple linear regression now. Okay, if you want to evaluate here, you can also do that. Okay, what I can just do is I can just use model.predict. I can predict all the inputs. Okay, and that entire things I can just put it in the predictions. Okay, now if I just check RMSE of target, which means actual data, and the predictions, this is the predicted data, your RMSE value is 4662 for the single feature. Okay, which is quite interesting, right? Yes. And you can see that if you want the intercept value, you can use the function model.intercept underscore. It will give the intercept value. And if you just use model.coef, you'll get the coefficient value. If you do that, you can see your line will come somewhere here. Try parameters. If you have observed previous step, I had given W value and the B value, intercept value, right? The same value. Model coef is nothing but this is the value, 267. And model intercept is nothing but this is the value, minus 2091, and based on that value, this is how the regression line got created. Okay, so in this specific chart, can you tell that your model has learned quite good nice patterns? Is it closer? Is it effective? Yes. Good. Yeah, it is also good. Yes, yes, agreed. Okay. Already we have discussed about like machine learning flow here. You can see first there will be some input data. You'll put the model, that is any kind of model, linear regression. Then that linear regression model will give the output. It will check with the loss function. If the loss function or the error rate is too high, again it will go under the optimization. Again it will come under the model. Again it will give the output. Like that, the entire procedure will go ahead. Yes. See, there are few outliers also. Yes, in the chat box, like Ruben have mentioned that outliers. Yes, you can also clean the outliers and you can just uh, create the model so that you can get much better result as well. Yes. Okay. Sorry, my mistake. Now let us go ahead with the linear regression with multiple features. Now, previously, if you remember one thing, we had used non-smoker data only, right? In non-smoker data, we had used only age column. Now this time what I'm doing here, I'm just using inputs, targets as the variable name. And over there from the non-smoker data, I'm including age, BMI and children as the inputs. Three things I'm including here. I'm including the age, I'm including the BMI and including the children. Three columns I'm including. And what is your target? Target remains same, non-smoker data, and that column is nothing but charges. Okay. Once you split the inputs and targets again, what you'll do? You'll create the model. Okay. In that model, what you'll tell? Your model is nothing but the linear regression. And in the same line, you're gonna fit. If you want to use multiple lines, you can do that. But to make time efficient and to make it much quicker, what I have done, I have applied in the single line itself. Okay, so directly I have applied linear regression dot fit. I'm passing the inputs and targets. And what is your inputs now? This time your inputs are nothing but age column, BMI column, and children column. These three things are nothing but your inputs. And what is your targets? Your targets is nothing but the charges. Okay. Then what you'll do? You'll do model dot predict the inputs, and you'll store all the values in the predictions. Okay. Then you'll check the loss here. To check the loss, again I've applied the RMSE value and I'm putting targets and predictions. Now let us see the difference here. Now if I just try to run here, I'm getting a RMSE value of 4608. Previously, what was the RMSE we were getting? 4662, right? So we had only specific age column, right? We had only age column. Age column had the loss of 4662. But here I have included two more columns, that is BMI and children. And if you are aware that BMI also had a small correlation, okay, that was a reason, like there was a reduce in the loss as well. Previously we had a loss of 4662 and now we have the loss of 4608, which means we have reduced few much value. So you have to also remember one thing, as much the loss you gonna reduce, that much the model will be developed, the betterment of the model will be. Okay, yes, if you just check the correlation of BMI and the charges, it is telling 0.8 here, which means 8%. Okay, yes. If you want to check coefficient and intercept, you can get the coefficient and the intercept value. And here again we have the children value. To check the children, you can see uh, these are the from the entire data set. Like a lot of people have 0 children, and these are the count of the people who had 1 children. And you can see the people who have 5 children, they don't have much medical expenses. We have understood one thing here, right? Yes. Okay. So this is one scenario what we have understood. Okay, and we believe that a lot of people don't have 5 children. There are few people. Okay, you can see you can also count the data points here. Okay, so this was the same thing what we have plotted, 4608 from the RMSE loss. Okay, now you can imagine here we have applied the non-smoker data. There are smokers also. What if I include those people in the model? Okay, let us apply those people also. Let us see what is the loss we are getting this time. Okay, now I'm taking the entire medical DF now. From the medical DF, I'm including age, BMI, children. Okay, and charges from the medical DF. I'm applying the linear regression, I'm applying the fit function, and I'm applying the targets also, targets and inputs, so that it can get trained. Now, if I just try to run this, you can see I'm getting the loss of 11,355. Okay, now remember one thing, students here. So in non-smoker data, the maximum medical charges of a person was something around 32,000, 33,000, because non-smoker people were not having that much high medical charges. But smoker people had the medical charges like 64,000, 55,000, 60,000, etc. There were quite high value, right? So for those kind of value, it is giving the loss here. It is giving 11,355, right? Now, if you want to create a chart and you can, if you want to do it, you can also do that. But if you want to reduce these values, you can give the new inputs here. What are other inputs you can give so that your model can work much better? There's another column called smoker. In smoker, we had categorical values, yes and no. Okay. Now directly you cannot give yes and no to the model. Why? Because it will throw an error. Your model will never understand what is yes, what is no. So what you have to do? You have to convert that into the numbers. To convert that into the numbers, there is encoding technique. Okay. So what you can do is first you can apply the binary encoding. Binary encoding. Yes. You can see we have a value called yes and no. This is the count of the people who are telling yes and who is telling no, the smokers. Okay, so I'll just convert the values. Wherever there is a value called no, I'll make it as 0. Wherever there is a value called yes, I'll make it as 1. And all the values I'll reflect into the original data set. Okay, and I'll save it in the column name called smoker code. Okay, there is a column called smoker code now, and we have the value called 0 and 1. Let me show you. So here you can see we have a column called smoker code now. Extra column we have created by applying this binary encoding technique. Now what is happening here? If the value is S, basically means the value will become 1. If the value is no, means the value is 0. No is 0, or yes means the value is 1. That is what I have applied. Why I have given this one? Because your machine learning model will understand only the numbers. Your machine will not understand what is yes, what is no. No, it will not understand that way. Okay, you have to convert into numbers, then you have to give it. Okay, let's see how exactly it goes now. Now this time I have given the age, BMI, children, and smoker code. Okay, I have given the smoker code column now this time, and these are the inputs now. And medical charges is the targets. Again, I'm trying to apply the linear regression model, and I'm fitting the inputs and targets. Now, if I just take out the predictions now you can see you are getting the loss of 6056 RMC value, which is quite really good, right? So there was a huge impact of the smoker code. Your model has learned a lot of things. Your model has reduced the error almost 50%. You're off by 50% now. You can see here. From 11,355 RMSE, you got reduced to 6,056. Okay, so which is really which means your model is performing much better now. Now easily you can just tell that uh, if you classify some specific, if you want to check whether a person has the maximum medical charges, if you provide this specific data, age, BMI, children, and smoker code, your model will give much precise answer by giving the medical charges to you. Okay, now you can see that the loss is giving something like 6056, which is really good result. Okay, so there is one more column like we had region, I believe. Okay, let's try to put that one as well. But to apply that column, we need to see what data we have. Okay, we have the gender column as well. Again, we are applying encoding for gender as well. Wherever we have a female, we'll make it as 0, male as 1. Let us see whether we'll be having any impact on that. Okay. If you try to apply the gender code here, you can see we are getting 6056. Same result, I believe. Yeah, 6056.43. Here, yes, 6056.10. Okay, there was a marginal reduce in the RMSE. Yes, if you are reducing the small amount of value also, it is necessary, students. You have to keep these things in mind. Okay, as much you reduce the RMSE values, as much as you reduce the RMSE value, that much your model will perform really good. Okay, yes. Okay, now there are few things what you can go through here. We have a concept called one hot encoding. Now, why I'm telling you this specific concept here, one hot encoding, because there was a column called region. In the region column, there are 4 different values: southeast, southwest, northeast, and northwest. Okay, let me just show you here. Let me insert here. Okay, I'll just use this medical DF, and there's a column called region over there. In this region column, I'll just check all the unique values. Okay, now you can see that in the data set we have this one column as well, region, where we have the value southwest, southeast, northwest, and the northeast, and which is the object data type. So directly you cannot pass region column into the model because it will throw an error, right? It will throw an error if you directly pass the categorical data. You need to convert that into numbers. To convert that, we have one technique called one hot encoding. Now, what your one hot encoding does? It's really simple. You can see this is a column name, right? You can consider this is one of the column here, categorical column, and we have the values cat A, cat B, cat C. Okay. Now, if you apply the one hot encoding, Whatever the values you have, cat A, cat B, cat C, those will become the column names. Okay, those will become the column names. Here you can see cat A is one of the column, cat B is another column, and cat C is another column. Now what happens is, in the entire row, your model will check what is the value. If the value is cat A, okay, your one hot encoding, what it does, it will search for the column A. It will search for the cat A column. It will give the value as 1. For cat B and cat C, it will give 0. Okay, it will come to the next row. It will check the value. If the value is cat B here, it will search where is cat B column. It will give the value as 1. And for cat A and cat C, it will give 0. Okay, so the next row, it is cat C. It will search for the cat C column. It will give the value as 1. And for cat A and cat B, it will represent the value as 0. So that is how your one hot encoding will work. So students, just let me know, have you understood one hot encoding? If there are 4 different categories, yes, 4 different columns would be created out. Yes. Okay. So those who have not understood one hot encoding, no need to worry. In upcoming session, again, we're gonna implement these things. Okay. So where you can understand much better. Okay. So you can see that by creating the chart, we have understood the count of each region: southwest, southeast, northwest, and northeast. So these are the counts. To apply one hot encoding, these are the steps what I'm following. From the scikit-learn library, I'm importing pre-processing technique. And what I'll be doing, I'll just create a variable called encode. In that, I'll be using pre-processing dot one hot encoder because I want to apply the one hot encoder, right? So I'll be using that and I'll try to fit the entire region column. Once I do that, you can see my one hot encoder values is being created. Okay, this is how it got created. Now, this was the array. In the first value, we had southwest region, value as southwest. So for northeast, it is 0. Northwest, it is 0. South, it is 0. For southwest, it is 1. Okay. Similar way, it has been effected for each and every value, each and every row. Okay. So this is how one hot encoding works. Okay, now after converting into one hot encoding, we'll apply into the data set here. You can see the new columns got created out here. The column names are northeast, northwest, southeast, and southwest. Now we don't require the column called region anymore. We don't require that. We don't require smoker column as well. Why? Because smoker is being converted into the column called smoker code. Either we don't require gender column as well because the gender also got converted into the gender code column. Okay, so we can remove this categorical columns and we can use only the numerical columns now. Now to do that, again, I'm applying the same technique here. Here we go. Let us give the inputs. Input I'm giving as age, BMI. These are the column names. Okay. If you want to give the manual column names, you can give it, or else you can directly give it. Not a problem. Okay. I've given age, BMI, children, gender code, smoker code, northeast, northwest, southeast, southwest. These are the columns what I'm using for the inputs. And what about for the targets? Targets I've kept the same thing. That is nothing but the charges column. Okay. Now, once I separate all the inputs and targets, what I'll be doing, I'll just use, I'll create a model. Model is nothing but your linear regression. You can see here. Your model is nothing but linear regression. I'll apply the fit function. In the fit function, I'll pass all the inputs. I'll pass all the targets. This is nothing but your target is. Okay. And these are nothing but your inputs. Don't get confused here. Then you're gonna take out the predictions and you'll just check model dot predict and you'll check the RMSE. And what is the RMSE you're getting this time? You are getting the RMSE value of 6041. Students, is my voice clear? Just a minute, just a minute. Sorry for the interruption.
Your voice is your screen is not shared.
My voice is clear, right? Let me just share the screen again.
Yes, yes, your voice is clear.
Yep. Okay. Just check. Is my screen visible, students? Students, is my screen visible?
Yes, sir.
Okay. So you can have a look here. Based on the inputs what I had given, we got the RMSE value of 6041. Okay. So this was the algorithm what we had used. That is nothing but linear regression, right? Now there are other algorithms also. In other algorithms, we can just get much better result. Okay. Those algorithms we have not yet discussed. Okay. But I'm going to discuss one of the algorithm that is nothing but random forest. Okay. So random forest is also one of the algorithm where we can either solve the classification problems, and along with that we can also go ahead with the regression problem. Both the things we can solve. Okay. So we can also solve classification, we can also solve regression also. Both the things can be solved. And to make you more understand, let me also include one more point, that random forest is also considered as one of the powerful algorithm in machine learning. Okay. So it is also called as one of the powerful algorithm. So in upcoming session, I'm going to explain how exactly this random forest algorithm will work. But to show the practical implementation, what I'm going to do is I'll just use from scikit-learn library. I'm using the ensemble technique, and I'll just import the random forest regressor. Okay, look at the algorithm name here. The algorithm name is random forest regressor. Okay, but if I need to use for classification, means I had to use random forest classifier. Okay, but this is the case study what we are trying to find out the medical charges, right? So I'll be using random forest regressor. Okay, so in the random forest regressor you can have a look. I'm passing the inputs and targets. What are your inputs? Your inputs are nothing but age, BMI, children. The same thing whatever you have given for the linear regression, the same thing you have given. And you have created another variable called as model RF. Okay, and you have changed the model name here. The model name is random forest regressor this time, and you are trying to fit this. And what you are trying to fit with inputs and targets. Then you are trying to take out the predictions. Then you can take out the loss here. Now once you do that, here you can see this is what your RMSE values, that is 1837. You're off by this value, which means you can see how your random forest is working compared to linear regression, right? So compared to linear regression algorithm, your random forest regressor is giving much better what RMSE value, right? So this is how you can just create the model. Okay, now let's believe that if you just want to try to predict new things, which means let's believe that you want to predict for new data, you need to pass the inputs. So how you can give the inputs? Let me just remove this. Okay, so here what you can just do is you can use model rf.predict, and in the predict function you can start simply passing the inputs here. The first input is nothing but age. Okay, let me just pass the age as something called 60. Okay, I'm randomly passing. It's up to me whatever the values I need. Okay, so let me pass the BMI value something around like 52. These are just example. Then children, let me just make it as 1. Then we have gender code. Gender code, let me just give it as 0, which means she is a female. Smoker code, let me give as 1, which means the person has a habit of smoking. Then northeast, I'll give it as 0. He doesn't belong to northeast. Northwest, yes, I'll give 1 as northwest. Why? Because he belongs to northwest. Southeast, I'll give 0. Southwest also, I'll give it as 0. Okay, so these are the inputs, and based on the inputs, let me just try to run this. Now, once I execute this, you can see that your model is giving that based on the data what I have provided. This is the maximum medical charges the person can be bearing. That is $58,149. Okay, so this is how your model is giving the predictions for you. Students, clear? Okay, let us see by changing few values here. Now let me marginally reduce the age column here. Let me give the age as 19 and smoker code, which means it is in the 5th value, right? 35. Okay, let me make it as 0 here. Okay, and BMI also let me make it as 25. Everything I'm making in the normal range. And if I try to run this, you can see how your model is predicting. Your model is predicting that it's only 3098, which means his entire value seems reasonable and he is perfectly fine. He's healthy and he's a teenager. He doesn't have the habit of smoking. He will not be having that much medical expenses. It is only 3098. But once I give smoking habit as yes, and once I increase the age value, automatically there will be a increase in the expenses also. That is how you can just create your machine learning model. Student, is that clear to you? Any doubts still here? Was the project interesting? Students, I want your views. Yes. I believe that you have understood each and every step, right? Yes. See, there are few more things what I need to highlight. One thing is students, you keep on asking what kind of projects you have to be submitting, right? So make sure that you can create any kind of AI project. That is one thing. Okay, if you are really good at machine learning, you can create a project related to machine learning. If you are interested in deep learning, you can create the project on deep learning, any AI related project. Even the chatbots are also fine. You can use the APIs. Yes, you are allowed to use that, but it should be related to artificial intelligence. Not only that, you also have to complete the courses what we have assigned to you in the MS Learn, in the LMS portal. Okay, so complete the course first, and don't forget to post your certificates in the LinkedIn, and you can also tag us. We have Shilar sir, we have Piyush sir. Okay, and I'm here. Okay, you can tag us and you can just post your certificates as well. Okay, so kindly complete all the courses and kindly work on the projects what we're gonna work with. And yes, we're gonna have upcoming new projects, okay, in upcoming days, very quite interesting related to unsupervised learning, deep learning. Okay, so stay tuned and go with the flow. So Karthika ma'am, do you have any updates for the students?
Topic, sir. It is already shared. Um, but some students, they keep on asking, ma'am, I missed the session. What should I do? I couldn't join the group and all that. See, students, if you're registered in the AICTE platform properly for this May month internship, you could have you might have received the email to the AICTE registered ID. You can check it in the inbox or spam. Like somehow you might have received it. Okay. And even if you delete the email by mistake, you still have the trash option. You can go back and check for the Telegram group link, because that is the only group where we can send the updates about each and everything. Right? The in and out of the program will be shared in the Telegram group only. Okay, and we cannot just randomly share the Telegram group link with everyone, because only the AICTE registered students can be there. Okay. One of the students, you kept on asking for the same thing in the YouTube chat, but this is the truth. Okay. So kindly check your AICTE registered email ID multiple times in multiple folders. You will be able to get the details. Okay. And for the project related details, in everyday session, we keep on sharing the updates. Also, we will be sharing, most of the updates on the AMA session. And it's a very live session. We won't be able to provide you the recordings. Please do attend that. Okay. So these are few things that you need to know, and kindly start working on your projects and do complete the courses. Okay. On your LMS. And some of you are saying that the offer letter is not visible. See, for that, you need to use only your AICTE ID as instructed. If you want more details, you can always refer to the guidelines documents which we shared in your Telegram group. Okay. Thank you all so much. Thank you, Tawfiq sir. And thanks everyone.